what happens here is there are three other ways that you get angles in a circle, and they are horribly, horribly, horribly wordy. Which, in other words, don't look at your textbook. It will screw you up, okay? The terminology and the verbiage that they use sucks. It is a technical way of writing it out. This is much, much easier. Outside, inside, on. If you can depict one of these three pictures, and then it's just a matter of following a very simple plan, okay? So let's go through them. So what happens here is that if you have a circle, and we'll start with the outside. If I have two segments that meet outside, how many arcs do those two lines run into? Two of them. One of them is far away, the other one is close. Everybody okay with that? What's that? All right, so if you're okay with seeing that you have an arc here that it runs into and an arc here.
Oh.
There's a far and a close.
Yeah, sure.
Well, if I'm here, which one's further away? This one or that one? Okay, I think we can all figure this out. So here's what happens. There's a very easy way of writing this out. The angle equals half the far arc minus the close arc. It's the easiest way to write this. The far arc minus the close arc. So if you're outside the circle, if your angle is outside the circle, angle equals half the far arc minus the close. That's a lot easier than saying a lot of other things that they write out. Okay? Let's do the next one. Inside. If I have inside, when you have two segments that intersect inside a circle, how many total different angles really are there? There's only two of them. Very good. There's only two of them because you have vertical angles and then you have supplementaries going around it. That doesn't change as far as what we've done in the past in terms of rules. Okay. Now, what happens here is that depending upon which angle you have, it also means it's looking at two different. Could be looking at two other sets of arcs. Now, if I label this angle X, which other angle is the same angle? The vertical end. So these two are the same angles, right? We're okay with that. And then these two would be the same. So what I do is, if I'm given the one angle here, this angle looks at two arcs. It's looking at this one. And since it is the same angle down here, it's also looking at this one. Because of vertical angles. Are we okay with that? And are you kind of not quite sure? You're okay, this angle looks at the red arc. By rules of vertical angles, these two are exactly the same, which means it's also looking at this one.
Wait. There is a rule for vertical angles?
Yes, Wister, we've talked about this many, many times. Stop.
I just forgot.
So here's what happens. Your angle is going to equal half the sum of the two arcs it hits. Okay? It's going to equal half the sum of the two arcs it hits. Think of it as an average. All right? So if you're inside, your angle equals half the sum of the two arcs it hits. All right? So we've got outside, far minus close, take half. Inside, arc, take half. And then on is the last one.
But Mr. Murphy,
Yes.
for the other two,
Mhm. It would be the exact same rule. If I placed one here, this angle would equal half of this arc plus this arc. It's the exact same rule. Okay. And it doesn't matter, you could be looking at either set, it just depends on the problem. Okay. And the last one is on, and this one's the easiest. When we have two, it's the easiest way to draw this. If I'm on the circle, that means my angles, my vertex lies on the circle. We already know something about what happens when your angle lies on the or when your angle lies on the circle. What was that if it was inscribed angle? Half of the arc. Well, this is not technically an inscribed angle, but its vertex lies on the circle. So let's take a guess. What do you think the rule will be?
The same thing.
Same thing, yeah. It's half the arc that it hits. So when you're on the circle, your angle equals half of the arc it hits. So this angle opens up and hits this arc. So that angle will equal half of that arc. Outside, far minus close, half. Bless you. Inside, arc plus arc, half. On, half the arc. So this angle would equal half of the arc that it hits. So much cleaner to remember it this way, as opposed to any of the other ways that of all the long-winded definitions that the book puts stuff together. Because everything boils down to just knowing, are you outside, inside, on? If you can determine that, which I'm pretty sure you'll be able to figure out, you're going to be okay. All right? Let's look at examples. Arc in, at the arc. All right, so let's start with one. So we have a circle, and then we have an angle created. Was this angle created by outside, inside, or on? On. So that means the angle's going to equal half of what?
280, 228.
Correct. So if I'm looking at this, since this is an on, this is an on, so our angle equals half the measure of the arc.
Which is going to be 14.
So that means my angle is going to equal half of 228. And there you go. Outside, inside, on. That's all you gotta know. You guys know if you're outside or inside, right?
No.
I would hope.
What I know is that
Can I go to another one?
No,
It's getting old.
usually it's all.
What's that? What are you working on? Well, you know what's gonna happen, right?
It's gonna get hard.
Yeah.
There's gonna be algebra.
Of course. There will be algebra thrown into this, but it's the same idea. If you can replicate, if you know which parts you're looking at, all it is, it's either an angle, a far arc, a close arc. So it's gonna be 1, 2, you'll have 2 of these 3 that you'll have to work with. Same deal here, angle, arc, and arc. You have 2 of the 3 to work with. That one, there's only 2, so you're gonna have 1 of the 2. So, but what they can do, instead of finding where that angle X is, I might ask to find the other side of the arc, where you'd have to do your supplement and go through there, or sorry, subtract from 360 and whatnot, but it's not gonna be anything crazy. It really won't be. Because if you can understand how it is just gonna wind up being outside, inside, on, it's really, really quick. Okay? So is this one outside, inside, or on? It's inside. So therefore that angle is gonna equal half of the 2 arcs that it runs into. Well, this angle runs into an arc of 89, and since this is a vertical angle on the other side, it also runs into arc 63. So your angle is going to equal half of the sum of the arcs. So what is half of 63 and 89?
120.5.
76.
76.
What? What?
63 plus 89 equals, divide by 2 equals,
63 plus 89.
press enter.
Yeah, I've got this.
What your calculator did was half of 63 and added 89 to it. You have to, if you're going to do it this way, you have to put parentheses around this to make it work.
What did you say that before?
Well, do you see how I write it with parentheses? The reason why I write it with parentheses, so that way if you do it with the calculator, you type it just that way.
Oh, I never know that.
Outside? Oh, sorry, go ahead. What was that?
So, I know, I was just joking. So, her question was about, do we have vertical angles now?
Yes. Yep. Because now you know that if this is 76, then you know that this is 76. Therefore, this is going to be what? 104 and 104.
It's not the same.
They're not going to be the same because they're not at the center. If it was at the center, this still works because it's inside the circle. Okay. It would still work. All right, let's try another one. Outside, inside, on. It's outside. So let's draw it out. And you don't need to, what you have to be able to distinguish here is which one's further away from the angle. Right. Outside, inside, on.
It's 18, man.
Which is it?
18.
Let's walk it through the whole thing. It's outside.
It's not
So if it's
14,
outside,
so easy.
your angle is going to equal half the far arc minus the close arc. Well, our angle is half of 78 minus 42. And again, if you type it in the calculator exactly like that, press enter, you will get dun, dun, dun.
18. So it's gonna-
Far minus close. Take half of it.
I don't think you need to do all that. work.
No
You can just remember.
verbiage needed.
You know what I mean?
That's all you need to know. That's it. Because what are you looking at? You're looking at your arc. If you understand where you're looking at stuff, that's all you gotta have to worry about. And it works. works. It's clean. Very clean. And yes, there will be algebra. Yes, I know as much as you guys are worried about that. No, it's from an old file. I just forgot to change it up.
Could you just give us a worksheet?
No?
How about a break, man?
That's and like I had mentioned before, if you start to look through some of these things, you have basically when you have a problem like this, we're all okay saying that that's an outside problem because you have an outside angle. We're all right with that? If you have an outside angle, you have an angle, a far, and a close. There's 3 parts to it. In order, when you have equations then, you're going to have to know 2 of them. And then it's just a matter of, works out to be like a 2-step equation. So if we draw this one out, you have your angle, you have a far arc, and a close arc. Which one are you trying to solve for? The far or the close? The close. So here's what we do. We write it out. We know that this is going to be angle equals half the far minus the close. Well, what's your angle? 38 is half. What's the far? 180 minus the close. Well, in this case, I don't want to distribute the half, do I? What do?
Times it by 2.
Multiply everything by 2. Very good. Get rid of the fraction. Multiply everything by 2. So then I get, well, what's 38 times 2? 76. So 76 then equals 180 minus x. How do you move a negative x? You add it to the other side. At the same time, what do I do with 76?
Subtract 76 on each side.
And what's 180 minus 76?
If I was to multiply everything by 2,
Half the far
No.
minus the close.
What you're doing is
It literally is writing out those those statements. If you write out the statements, everything falls into place. Yes, Ms. Ross. You can do that. It does the same. No, and that's fine. And it works out fine. It's excuse me, because it's what you have to do anyway. All right, but don't forget, sometimes you might have to find the far one versus the closest. There could be other steps and all that, but what you're doing is, all right, let's do another one.
Wait, I'm going to be in algebra 2. So then I would want, if I'm going to be in algebra 2,
Okay.
I want to build this class so that way I won't get to algebra 2.
Just decide if you want to get to algebra 2.
If I don't want to get to algebra 2.
So in this one here, we have the 2 segments. Are they outside, inside, or on? They're inside. So after you draw it out, what you always want to do is write down the formula for inside. Since this is an inside setup, we know the inside is angle equals half the sum of the arc. Arc plus arc. Well, the 115 hits 2 different arcs. It hits the x, and it hits the 105. Therefore, the angle is half of 105 at x. Remember, it's an average. Get rid of the fraction. What do? Good. If I multiply 115 times 2, or just double it, you get 230. And now, lastly, what do? And you get what? 115? Well, we're building to it, because it's not always just x, it could be 3x minus 6. You know what I mean? So you might, it's, the concept here is just the same setups. Yeah, or this can happen, actually. What happens if I said, hey, I didn't give you this angle, but I said that this one was 65? Then you'd have to make the extra step to get to this one, so you bounce to get to that. So you have to work. Yeah, but it's adding that extra step to it. But it still comes with the basic idea of outside, inside, out. Okay. And here's kind of, as we were starting to worry about next case scenario. If you look at this one, we have the circle. Our angle is on the circle, but my value of x isn't the arc that I can find easily. The value of x is on the other side. That's all it winds up being. It's literally adding one step to things that you already know how to do. Or I'm sorry, it's adding something that you already know how to do to what we're learning today. It's just taking that one extra piece to it.
So it's going to be 180 minus.
There's actually two ways to go about solving this.
Can't you do 180 minus 96 to get to the other side of
Yes, that's one way. But the first way I'm going to do it is the on method. Then I'll go back to that one. The angle being on means that the angle is going to be half of that arc that it hits. We okay with that? So the on means that angle equals half of the arc. Well, 96 is my angle, half of that arc, which means, again, what do you do to get rid of the fraction? Okay. Double 96 and you get what? 92. So that means that arc in blue is 192.
Then we'll
Right.
take 360 minus
I'm a poet and I didn't know. So if this part's 192, to get and finish up around to the other side would just be 360. Subtract that, which is how much? So that gives you 168. Now, the other way to do it was what Whiskey was saying. If I go back to where the 96 degrees is on the diagram, you'll notice that you've got a line and an angle. Well, when you have two angles on a line, that means one angle is 96, the other side would be its supplement. What's the supplement to 96? Very good. The supplement to 96 would be 84, which means I could have used that side to get there. Same idea. The angle is half of the arc. Well, if I double 84, I get, it still works. Math, exactly. Okay? So there are multiple ways of setting up a lot of these. All right? There's only so many degrees in a circle.
Don't you hate math?
Okay. Adding the algebra. Adding a little bit more algebra. What's that? Because algebra is a rootin' tootin' good time.
Who is it? No, I don't. Who got this? This is not mine.
You're not sure.
That's 97.
So is this angle outside, inside, or on?
Come see it.
Where is it? It's on. Okay. So write out your formula for on. We know this is on. So angle is half the arc. What's my angle? Very good.
Yeah, I'm trying to answer.
See, like,
And then it's half of,
5x.
and once again, I don't want to take half of odd numbers. It's a pain. So what do? Multiply by 2, very good. So when I multiply over the other side, I'm gonna have 2 times the quantity of 3x minus 1, which is gonna be 6x minus 2 is 5x plus 33.
Oh, would you not?
You have to distribute to both parts in the
Yeah, but you
parentheses.
just go to the second parenthesis.
6x equals 5.
Right, because what's 2 times a half?
That's half.
35. Need subtract.
So you have you've got a quick 2-step problem here. Subtract 5x, add 2, what's x? Very good. So you will build into the algebra, but we just start as we go through, we just start it slowly, that's all. Okay? Outside, inside, on. That's all it is. What's that? Oh, really? I'll show you. Oh, the next one I'll show you how to do it. Yeah, this one's in. Very good. Move over a bit so it gets to work. Oh, excuse me. You guys got me yawning now. So, outside, inside, on. Inside. So, since this is inside, write down how you find the inside. Well, inside means its angle is half arc plus arc. Fill in the blanks. You know one of the 3 in this case. You know the angle is 38. The 2 different arcs are 10x minus 1, and the other one is x. So far, so good? Now, what's 10x minus 1 plus x? Very good. It's 11x minus 1. Everybody okay with that? Just combine the like terms on the inside here. So we have 38 is half of 11x minus 1. Do I want to take half of odd numbers? No. So what do? Multiply by 2 to the other side, to both sides. We had a 38 doubled earlier. It was 76. Good. So we have 76 is 11x minus 1. Now what do?
Plus 1 on each side, divided by.
Add 1 to both sides, we get 77. And what's x? 7. So notice, this was one of them that you had to do a little bit more algebra on there. But was it terrible algebra? No, because all you're doing is fill in the blanks. Outside, inside, on. Sir. Huh? Because you're not on. It's not on. It's not on, that's why. And 38 can, I mean, because also you start thinking about 38 could be an average, because that's all these are. 38 could be is an average of an infinite set of numbers. So you, to what number? Oh, yeah, no, because you're not on. I see what you mean.
What's yours?
Just follow. All right, because you're not on it. Oh, I was sorry.
Oh,
All right,
sorry.
click on the left one.
Where does this come from?
Oh, I leave it on here.
Okay.
So if you don't have it on your tab,
I
if
don't.
you just click here,
Okay.
and then it would
Sorry,
say
guys.
screen capture toolbar,
Yeah,
and then it'll pop up.
okay. And
So you
then
click the one on the left.
this here.
Yep.
Alright.
Now you'll have that plus sign. If you,
Alright.
you take that and you put your finger, oh, you don't have to drag it. Well, I was just gonna take a picture of that now.
Oh,
So as soon as you touch that,
okay.
now the next place you touch will start the rectangle.
Oh, okay,
So if you
alright.
start here, and then you just drag over it. And that should work. Like when it's
And
happening.
then it
It'll
opens
have
up-
some lines in it, because you see how it was lining when you
Does
did
it
it?
automatically open up a tab for you then?
It already had a notebook file open, so the notebook, it jumps into the present open notebook file. If you
Okay.
don't have a notebook file open, it will open notebook and place it.
Got it, okay. And then
Try
just
again.
make it big. Okay.
That's
alright.
it, fast.
Yeah, be a little bit quicker. So
Stop! Alright, there, and now it's gonna open.
It might be a
And
lot.
save it,
yep,
and then I.
click your tab. I know I have 4,000
You got
tabs.
it now. And then we make it. Thank you. No, please. And I advance from using the chalkboard.
Why were we clapping?
This one's a little bit weird. This one's a little bit weird. This might. Well, is the angle outside, inside, or out? It's still outside. Yes, it's still outside. So we know that we have an outside angle. But what we have to do is we have to figure out, how do we make this work? Well, start by knowing that it's an outside problem. Write it out. Angle. Half far minus close.
Yeah, we already know how to do that.
Okay? You only know one of the two arcs. Which one? The far or the close? The close. You know that the close arc is x. Well, if this much is x, how much is on the other side? No.
How
You
many-
start this over.
Yeah, how many degrees
If-
are a circle?
If this is
Minus
10
that.
degrees, how much is left on the other side? 360 minus 10. If this is 100 degrees, it would be 360 minus 100. So this would be 360.
Minus x.
So now you have a little bit more work to worry about. And this is where you have to be very careful with your signs, S-I-G-N's. 45 is your angle. Half of the far, 360, minus x, minus the close. What's -1 minus 1? -2. So I'm going to get 45 is half of 360 minus 2x. Can I take half of even numbers, or do you want to double it? Just double it again? It's fine. Double 45, what do you get? Let's make our variable positive. How do I make a -2x positive?
Plus 2x on each side.
Add 2x, and then how do I move the 90 back?
Minus 90.
Minus 90. So I'm going to get 2x. And then what? 5 by 2, and you get? Okay. Let me give you some problems here before we get out of here.
I shouldn't have held on. Yeah. I don't. See this piece on my hand back. That's how we do it. If you first,
Let's get up through do those. You're probably going to need a separate sheet for some of the algebra from like 13 through 18, but for the first chunk you might be able to figure out relatively quickly. All right? Good, good? Yeah, you don't need any vocabulary. There's no